A Country in the Dark. It is the night of the 16th of November, 1996. The place is Baikonur, a sprawling launch complex set down on the flat frozen steppe of Kazakhstan, where the air in November is cold enough to sting the lungs, and the sky is wide and black and scattered thick with stars. There is no city here to dull the dark, just the steppe stretching out in every direction, the low hum of machinery, and a single tower of light rising from the plain. On the pad stands a proton rocket. It is tall, painted white, lit from below by floodlights, breathing thin curls of vapor into the freezing dark. Frost gathers on its skin. Inside its nose cone rests a machine that has taken the better part of a decade to design, to argue over, to fund and refund and build. A machine that carries the hopes of scientists in more than 20 countries. A machine that is meant to fly all the way to Mars. The launch is set for the evening. Engineers move quietly through their final checks, their breath fogging in the cold. Somewhere in a control room, men who have spent their entire working lives chasing the red planet sit before their screens and wait. They have waited a very long time for this night. Some of them have waited their whole careers. Because this is not an ordinary launch. To understand what is about to happen and why it matters so much, you have to understand the country that built this rocket. You have to understand how high it had once climbed and how far it had recently fallen, and how close it had come to losing everything it had ever built. 5 years earlier, in 1991, the Soviet Union had ceased to exist. The vast empire that had launched the first satellite into orbit, the first human being into space, the first probes to the moon and to Venus, that empire had simply dissolved. It came apart not in a single dramatic moment, but in a slow unraveling, republic by republic, until one day the flag that had flown over half the world was lowered for the last time. What remained in its place was a new Russia. Struggling, impoverished, uncertain of its own borders and its own future. The space program that had once been the pride of a superpower now survived on scraps. The grand institutions still stood, but the money that had fed them was gone. Salaries went unpaid for months at a time. Brilliant engineers, men and women who had trained for decades, drifted away to other work or to other countries, simply to feed their families. The factories grew cold, the clean rooms emptied, and the people who stayed grew older, with no younger generation coming up behind them to learn what they knew. This last wound was perhaps the deepest. A whole middle generation of scientists and engineers had been hollowed out, lost to the brain drain of those desperate years. It left a gap in the workforce, a missing rung in the ladder, so that the old experts had no one to pass their knowledge to. One scientist would later describe it almost as the aftermath of a war. The damage was not only to budgets and buildings, it was to the living thread of expertise itself, the unbroken chain of mentor and student that holds a great endeavor together across the decades. And yet, in the very midst of all this, a small and stubborn community of scientists refused to give up on the planets. They had touched greatness once, and they remembered it. In the 1980s, Soviet spacecraft had flown to Venus and released balloons into its burning sulfurous atmosphere. They had flown past the comet Halley alongside a small flotilla of probes from Japan and from Europe, in one of the great moments of international cooperation in the history of spaceflight. For a brief, shining stretch of years, it had seemed that almost anything was possible when nations reached outward together. That spirit had not entirely died. It had only grown quiet and folded itself away and waited for a chance to return. Mars 96 was that chance. It was the last best hope of a community determined to prove that the dream had survived the fall of the empire that birthed it. And it was no modest undertaking, no cautious first step. It was enormous. The spacecraft weighed 6,180 kilograms, fully fueled and ready to fly. That single number made it the heaviest interplanetary probe ever launched by any nation, by anyone in the entire history of spaceflight up to that time. Nothing built to leave Earth for another planet had ever weighed so much, and it was not a single craft but a small fleet folded together into one. There was an orbiter 3-axis stabilized, holding itself steady against the stars, its body studded with instruments, and its solar panels reaching out like wings. There were 2 small autonomous stations, each one designed to settle gently down onto the Martian surface and live there alone, taking measurements through the long Martian days and the bitter Martian nights. And there were 2 penetrators, slender darts meant to be flung down from orbit to strike the ground hard and bury themselves in the rock, listening to the planet from the inside. It was not just a spacecraft. It was a campaign of exploration, an entire scientific program, an observatory, and a network of outposts, all riding on the strength of one rocket and one launch and one cold November night. And the people who had built it, the people who had given years of their lives to it through the hardest decade their country had ever known, could do nothing now but stand back in the freezing dark and watch and hope. The ghost of Phobos. Every spacecraft has ancestors. Mars 96 had two, and both of them had failed. In the summer of 1988, the Soviet Union had launched a pair of identical probes toward Mars and toward its strange, small, potato-shaped moon Phobos. They were called simply Phobos 1 and Phobos 2. They were among the most ambitious robotic missions ever attempted by anyone. They were designed to study the little moon up close, to hover near its surface, and even to fire beams at it from orbit, so that instruments could read the cloud of material that scattered up. It was the kind of mission that pushed at the very edge of what was possible. Phobos 1 was lost on the way. The cause was almost heartbreakingly small. A single command sent up from a ground station contained an error. That faulty command switched off the spacecraft's attitude control system, the system that kept it oriented correctly in space. Without it, the probe began to drift, or lost its lock on the sun. Its solar panels, which had to face the light to make electricity, turned slowly away into shadow. The batteries drained, and in the cold and the dark, the spacecraft fell silent and never woke again. It was still months from Mars. Phobos 2 did better. It survived the long journey. It reached Mars. It slipped into orbit around the planet and began its work, returning images and data, edging closer and closer to its true target, the little moon. And then in March of 1989, just as it was preparing for its closest approach, just as it was about to do, the very thing it had crossed the solar system to do, it fell silent too. Something failed aboard the craft. The last pictures it ever sent home showed Phobos hanging there in the dark, a battered gray world only a short distance from triumph. And then there was nothing. The probe was gone. 2 spacecraft. 2 failures. A heartbreaking pattern that seemed to dog Russian missions to the Red Planet, almost as if Mars itself were inhospitable to them. As if the planet turned them away again and again at the threshold of success. Going back through the decades, the Soviet record at Mars was a long litany of probes that almost made it, that reached the planet only to falter, that completed a fraction of their work and no more. Triumph at Venus, at the moon, at Halley's Comet. But Mars remained stubbornly, painfully out of reach. Mars 96 was built from the bones of those 2 Phobos probes. It was not a wholly new machine. It used the same basic design, the same family of systems developed by N.P.O. Lavochkin, the great aerospace bureau that had built the Phobos craft and so much else. The engineers there knew exactly what had gone wrong before. They had pored over the failures, traced the faults back through the wiring and the software and the procedures, and they believed, they genuinely and deeply believed, that they had found the weaknesses and corrected them. But belief is not the same thing as proof. The value of all those careful corrections, all that second-guessing and redesign, could only ever be demonstrated by a spacecraft that actually flew and worked and reached its destination. Until that happened, the improvements existed only on paper and in the quiet, hard-won confidence of the people who had made them. They had fixed the old problems, they were sure of it. But the universe does not grant certainty in advance. It only delivers verdicts after the fact. The mission had also been a very long time coming, far longer than anyone had wanted. It had originally been conceived as 2 spacecraft to be called Mars 94 and Mars 96, launched in 2 successive windows. And here is something worth pausing on, a fact about the cold mechanics of spaceflight. Mars and Earth do not stay close to one another. They circle the sun at different speeds, drifting apart and then drawing near again, and the moment when a spacecraft can make the crossing efficiently comes around only about once every 26 months. Miss that window, and you must wait more than 2 years for the next. The planets keep their own schedule, indifferent to budgets and politics and human impatience. So when the money was not there, everything slipped. The chaos and poverty of the early 1990s pushed the whole program back. Mars 94 became Mars 96, sliding into a later window. Mars 96 was meant to be followed by a Mars 98. But Mars 98 was sketched, considered, and then quietly cancelled, lost to the lack of funds. In the end, only one spacecraft would ever fly. A single probe now carrying the entire weight of a program that had once dreamed of sending several, that had imagined a sustained campaign of exploration spread across years. And so Mars 96 became something more than a mission. It became a symbol and a test. It was the first Russian deep space mission to venture beyond the orbit of the Earth since the collapse of the Soviet Union. The only one of the entire decade. There would be no backup waiting in a clean room, no second probe held in reserve, no quiet contingency if this one failed. The program had spent everything it had on this single attempt. Everything rested on this one night. This one rocket. This one fragile, unrepeatable chance. The long Russian road to Mars. To feel the full weight of that night at Baikonur, it helps to look back even further past Phobos, into the long and sorrowful history of an entire nation's relationship with one particular planet. The Soviet Union had been reaching for Mars for a very long time, since the earliest days of the space age. Across the decades, it sent something on the order of 19 spacecraft toward the red planet. An extraordinary number, a sustained obsession spread across many years and many launch windows. Probe after probe was built, fueled, and flung outward across the gulf between the worlds. And the record of those attempts is one of the most painful in the history of exploration. Of all those many spacecraft, only a handful ever even reached the Martian system, and not one of them ever completed more than a fraction of the scientific work it had been built to do. Again and again the pattern repeated. A spacecraft would be lost on the way, falling silent in the dark long before arrival, or it would reach the planet only to fail in orbit, or it would send back a few precious moments of data and then go quiet forever. There were probes that died at launch, probes that died in transit, probes that died at the very threshold of Mars in sight of the goal. It became something spoken of half in jest and half in genuine unease, as a kind of curse. Mars, the scientists would say, had always been an inhospitable planet for them. The Americans had found far more success there. But for the Soviets and then for the Russians, the red planet seemed to turn its face away time after time, as if it simply did not wish to be visited by them. It was a strange and bitter contrast. This was the nation that had reached Venus, that hostile, crushing, sulfurous world, again and again with stunning success. The nation whose landers had touched the surface of Venus and survived long enough to send back pictures from a place that should have destroyed them in moments. The Venus program had been a triumph, an unbroken chain of achievement from the mid-1970s into the mid-1980s. But Mars, the gentler planet, the cold red desert that seemed so much more welcoming than Venus, somehow always slipped away. There was no rational reason for it, no single cause. It was simply a long accumulation of bad luck and small failures, and ambitious designs pushed perhaps a little too far. But to the people living through it, launch after launch, loss after loss, it could feel almost personal, as if the planet itself were withholding something it freely gave to others. By the time Mars 96 stood on its pad, this whole long history pressed down upon it. The probe did not fly alone. It carried, in a sense, the ghosts of all those earlier attempts, all those silenced spacecraft drifting somewhere in the dark or scattered across the Martian plains. It was meant to be the one that finally broke the pattern, the one that proved the curse was no curse at all, only a run of misfortune that careful engineering and international cooperation could at last overcome. The redemption of a 19-mission heartbreak. And the people who had built it knew all of this. They knew the history they were carrying. They knew that no Russian spacecraft had truly succeeded at Mars, not once in all the long decades of trying. They knew that this single probe, this last and heaviest and most ambitious of them all, was being asked to do what 19 others had failed to do, and to do it for a nation that could no longer afford to build a 20th. That was the weight upon Mars 96 as it climbed into the November sky. Not just its own great mass of instruments and fuel, but the accumulated longing of generations of scientists who had given their lives to a planet that had never once let them in. It is worth lingering, too, on what those 19 attempts had actually cost in human terms. Each one represented years of labor by hundreds, sometimes thousands of people. Engineers who spent their best years designing systems that would fly once and then fall silent. Scientists who built instruments they would never receive a single byte of data from. Whole careers measured out in spacecraft that did not survive. There is a particular melancholy in that kind of work, the work of building beautiful machines for a planet that keeps refusing them. And yet they kept doing it. Generation after generation they returned to the same red planet with the same hope, and met more often than not the same silence. Some of the failures had been almost cruel in their timing. Probes that traveled for months all the way across the void, performing flawlessly only to fail in the last moments before they could deliver their science. Spacecraft that reached Mars that actually arrived, and then died on the doorstep. It was as if the planet allowed them close again and again, only to turn them away at the final step. The closer they came, sometimes the more painful the loss. By the 1980s, with the great run of Venus successes behind them, the Soviet scientists had good reason to believe their luck at Mars might finally change. They had learned so much. Their engineering had matured. They turned their attention back to the red planet with real and justified confidence. And that confidence produced the Phobos probes. And then, after the Empire fell, it produced Mars 96. The whole arc of that renewed effort, the careful rebuilding of ambition after years of focus elsewhere, came to rest on these few spacecraft. Mars 96 was the inheritor of all of it. Every lesson, every hope, every hard-won scrap of expertise from a nation that simply would not give up on Mars no matter how many times Mars gave up on it. 21 nations, one machine. There was something quietly beautiful about Mars 96 beyond its great size and its towering ambition. It was, in a very real sense, a machine made by the world. Not by one nation alone, but by many working together across borders that had only recently been the hard edges of a divided planet. The mission drew on the work of scientists from 21 countries. 21 laboratories in France designed and built instruments. A university in Germany and the old city of Braunschweig constructed delicate sensors. Researchers in the United States contributed hardware and expertise. There were contributions from across Europe and from further afield, a whole web of cooperation stretching across the map, threading together institutions that only a handful of years before had stood on opposite sides of the Cold War. The scientists who had once been told to regard one another as adversaries were now bent over the same blueprints, fitting their instruments into the same spacecraft. It was perhaps the finest expression of that old hope. The belief, born in the bright cooperative years of the 1980s, that nations could achieve far more by reaching outward together than any of them could ever achieve alone. The sheer size of the spacecraft was matched only by the breadth of the collaboration that had built it. The two things went hand in hand. It was big because it was shared, and it was shared because the dream was big. The orbiter alone carried an extraordinary suite of instruments, a payload of remarkable richness. There were 12 separate devices dedicated to studying the surface and the atmosphere of Mars. Cameras to photograph the terrain, spectrometers to break apart the light and read the chemistry written in it, sensors to map the lay of the land and to measure the thin, cold carbon dioxide air. Then there were 7 more instruments dedicated to the invisible world around the planet, to the plasma and the magnetic fields, and the streams of charged particles that flow out from the sun and wash against Mars like a tide. And there were 3 further instruments built for astrophysics, pointed not at Mars at all, but outward into the wider universe to study gamma rays and the deep background of the cosmos. While the spacecraft made its long journey and its patient orbits, it was in effect a flying observatory, a laboratory lifted into orbit, a single machine designed to study the red planet from every angle at once, from its rocks to its air to the space that surrounded it. But the orbiter, for all its instruments, was only the beginning. Folded against the body of the spacecraft waiting to be deployed were the 2 small autonomous stations. Each one weighed only 32 kilograms, and that figure included the airbags that would cushion its fall to the surface. 32 kilograms. A small thing. Light enough that a person could gather it up in their arms. And yet each of these little stations was a complete and self-sufficient scientific outpost, a tiny robotic explorer, meant to live alone on the surface of another world. This was the marvel of them, the elegance of the engineering, with only a fraction of a single watt of power to draw upon a mere whisper of electricity. Each station was meant to support a genuinely ambitious program of science. There was a panoramic camera to photograph the landscape all around, to show us what it would be like to stand on that spot and turn slowly in a circle. There was a seismometer to feel the faintest trembling of the ground. There was a magnetometer to sense the planet's magnetic field, and an instrument to detect oxidants in the soil. the very chemicals that might tell us whether life could survive there. And there was a small weather station to record the thin Martian winds, the drifting dust, and the slow swing of temperature from the deep frozen night to the pale cold day. The two stations were meant to come down in the Amazonas and Arcadia regions, gentle plains in the northern reaches of Mars, where they could settle and listen and watch for a full Martian year and more. The seismometer mounted on those stations even had a name. It was called Optimism. Built largely in France, it was an instrument of careful, hopeful engineering. And its name was no accident. It was designed to detect Marsquakes, the trembling of the planet's crust, and from those tremors to begin for the very first time in human history, to map the hidden interior of another world, to take in a sense the planet's pulse, to feel through the rock the beating heart of Mars. And then there were the penetrators. These were the boldest part of the entire design, the most daring idea aboard the whole spacecraft. Rather than landing softly with parachutes and airbags, each penetrator was meant to be released from orbit and to plunge straight toward the surface like a dart, like a spear hurled down from the sky. It would strike the ground at speed and drive its forward section deep into the Martian soil, anchoring itself in the rock. There buried it would measure the temperature of the ground, the magnetism locked in the stone, and the seismic whispers passing through the crust beneath. Their short-period seismometers and their other delicate sensors had been built by the team in Braunschweig in Germany, the data gathered up and processed by the same electronics that served the Optimism instrument, two orbiting eyes high above, two listening stations resting gently on the plains, two darts buried in the rock below. Together they would have studied Mars from above on its surface, and beneath it all at the same time, weaving a single portrait of the planet from every layer at once. No mission before had ever attempted so much in a single launch. It was a magnificent, intricate, almost impossibly ambitious thing, the work of thousands of hands across 21 nations. And on that cold night at Baikonur it was about to fly. The long climb, at 48 minutes past 8 in the evening. Coordinated universal time, the engines lit. The Proton K rocket rose from the pad at Baikonur on a great column of flame, climbing through the cold November night, lighting up the steppe for miles around as it went. It shed its lower stages one by one, at each spent section falling away once its work was done, the rocket growing lighter and faster as it climbed. And in those first crucial minutes, everything went exactly perfectly as it should. The Proton worked flawlessly. This was a rocket with a long heritage, a workhorse that had flown many times, and it did its job that night without complaint. Stage after stage performed its task and separated. The great machine carried its precious cargo up through the thick lower air, up past the last thinning wisps of atmosphere, up into the black and silent vacuum of space. And within minutes, Mars 96 was traveling fast enough to fall around the curve of the Earth, rather than back down onto it. It had reached orbit. This was the first milestone, and it had been cleared cleanly and completely. The spacecraft was now circling the planet in a low parking orbit, roughly 160 kilometers above the surface, sweeping around the world once every 90 minutes or so. It was waiting for the next step in a long and carefully choreographed sequence, a sequence rehearsed countless times in simulations that would in time send it on its way toward Mars. That next step belonged to the fourth stage. This was a separate rocket unit called the Block D2. Sitting between the launch vehicle below and the spacecraft above. The Block D2 was an upper stage with a specific and absolutely crucial job to perform. It had to fire its engine not once, but twice. The first burn would refine and stabilize the orbit, settling the spacecraft into a clean circular path. Then, after a long coast of nearly an hour, the second burn would provide the great push. This second burn was the one that mattered most of all. It was the trans-Mars injection, the powerful kick that would break the spacecraft free of Earth's gravity entirely, and fling it onto the long, lonely road to the red planet. The first burn came, and it too was a complete success. From ground stations scattered across the vast width of Russia, controllers watched the data flow in across their screens. Measurements taken during the climb and during part of that first orbit confirmed exactly what they had hoped to see. A clean insertion into space. A stable, well-behaved orbit. A spacecraft healthy, responsive, and on course. The Block D2 had fired just as planned, and settled the craft neatly into its circular parking orbit 160 kilometers up. So far, every single thing was working. Every box was being ticked. After all the years of struggle and doubt, the mission was unfolding like clockwork. The plan from this point onward was elegant and patient and beautiful in its way. After the second burn sent it on its way, Mars 96 would coast for about 10 long months through the dark and the silence between the worlds, falling along a great curving path through empty space. It would arrive at Mars on the 12th of September 1997 on a direct trajectory. About 4 or 5 days before its arrival, while still approaching, it would release the two small stations to make their own fiery descent toward the surface. The orbiter itself would then fire its engine to slip into a long, looping 3-day orbit around the planet. And over the following weeks, the two penetrators would be sent down one after the other to bury themselves in the soil. The final orbit would settle into a long ellipse, carrying the orbiter close to the planet roughly every 15 hours, threading endlessly between its instruments above and the surface below. All of it lay ahead. All of that careful, intricate future depended now on one single thing: the second burn of the Block D2, the push that would transform a humble satellite of Earth into a genuine traveler to another planet. Everything that the 21 nations had built, every instrument, every dream, every year of work came down to this one engine firing on schedule for long enough. And so the spacecraft coasted on through the dark, swinging silently around the great curve of the planet, carrying its orbiter, and its landers and its darts drawing nearer, with every minute to the moment of decision. Below it, the night side of the Earth turned slowly past the lights of cities glittering here and there in the blackness, the oceans utterly dark. The mission clock counted steadily down toward the moment that would decide everything one way or the other. Then, as the orbit carried it onward, the spacecraft passed beyond the reach of the Russian ground stations. It moved out over a stretch of the world where no Russian antenna was listening, where there were no tracking ships waiting in the water below. It crossed into a gap in the network, a region of silence, a blind spot in the eyes that had been watching over it. And it was there, in that blind spot, out of sight and out of contact, that the second burn was scheduled to take place. The single most important event of the entire mission was set to happen in the one place where no one could see it, and no one could hear it, and no one would know what had occurred until it was already far too late. 4 seconds of silence. What happened next happened in the dark where no one could see it. The spacecraft was beyond the horizon of the Russian tracking stations. No antenna was pointed at it. No telemetry, no stream of data describing its health and its actions was flowing home to the waiting controllers. The most important moment of the entire mission, the burn that would either send Mars 96 toward another planet or leave it trapped forever at this one, took place inside a window of total unbroken silence. This is the cruelest detail in the whole story, and it is worth dwelling on. Had a single tracking ship been stationed in the right stretch of ocean below, had even one antenna somewhere been listening at that exact moment, the engineers might have known instantly what was happening. They could have watched the failure unfold in real time, and just as importantly, they might have understood in all the long years afterward exactly why it had failed, and so learned from it. But there was no money for tracking ships. The great Soviet fleet of tracking vessels, which had once spanned the oceans of the world to follow its spacecraft wherever they flew, had been sold off in the lean years, scrapped for cash, or left to rust at their moorings. The eyes that should have watched were closed. And so the single decisive instant of the mission went entirely unobserved. For reasons that are still to this day not fully known, the second burn terminated after only 4 seconds. 4 seconds. Consider what that means. The engine was meant to fire for far longer, for minutes long enough to add thousands of meters per second to the spacecraft's speed, long enough to break the heavy chains of Earth's gravity and hurl 6 tons of spacecraft onto a path to Mars. Instead, it sputtered to a stop almost as soon as it had begun. 4 seconds of thrust and then nothing. The great push that should have carried Mars 96 to the red planet simply and silently did not come. But the sequence did not stop there. This is the part that turns misfortune into something closer to tragedy. The spacecraft was running on its own internal program, a fixed script of commands written and loaded long before launch. And that program did not know that the Block D2 had failed. It had no way to sense the disaster. It only knew what it had been told to do next. And so it went on doing it faithfully, blindly, step by step. So Mars 96 separated from the spent upper stage exactly as planned. The two halves drifted apart in the dark. And then the spacecraft started its own engine exactly as planned. A final kick that in a healthy and successful mission would have added the last increment of speed on the way to Mars, a finishing touch to the great departure. But the spacecraft was not where it was supposed to be. The failed fourth stage had left it stranded in a low parking orbit far short of escape. And worse, far worse, it had left the spacecraft pointing in an unexpected direction in entirely the wrong orientation. So when Mars 96 fired its own engine dutifully following its program, it did not push itself toward Mars. It pushed itself the wrong way at a steep and ruinous angle. Instead of speeding the craft toward escape, the burn made everything worse. It raised the high point of the orbit, lifting the far side of the loop. But at the same time, it dragged the low point down lower and lower, pulling it down into the thin upper edge of the atmosphere to an altitude of only about 70 kilometers. And a perigee, lowest point of 70 kilometers, is a death sentence for any spacecraft. At that altitude, the air, though almost unimaginably thin, is still just thick enough to take hold. Every time the craft swung down to the bottom of its orbit, it brushed against that faint resistance. It lost a little energy. It slowed just slightly. And each loss compounded the next. Each pass through the upper air would drag the orbit lower still and lower again, the spacecraft falling a little further every time around, until at last there would be no orbit left at all, only a fall. The decisive moment had passed in silence, and in that silence, everything had already been decided. The spacecraft was not going to Mars. It was not going anywhere at all. It was caught now in a slow, certain, irreversible spiral winding down toward the very planet it had only just left behind a few hours before. Mars 96, the heaviest interplanetary probe ever built, the patient work of 21 nations, and very nearly a decade of effort, was falling home. And it had no idea, and neither yet did anyone on the ground. It is worth pausing here on the strange, almost unbearable irony of that program, the spacecraft's own internal sequence of commands. In a successful mission, it would have been a thing of beauty, a perfectly timed cascade of actions unfolding in the dark, each step flowing into the next separation and ignition and acceleration, carrying the craft smoothly onto its path. The engineers had written it with care, choreographing every motion. But that same program, in the moment of failure, became an instrument of the spacecraft's own destruction. It could not see what had gone wrong. It had no eyes for disaster. It simply executed its instructions faithfully, into a situation those instructions had never been written for. And in doing so, it drove the craft down rather than out. This is one of the quiet hazards of building machines that must act alone, far from any helping hand. They cannot improvise. They can only do what they were told with perfect obedience, even when perfect obedience leads them to ruin. The spacecraft did exactly what it was designed to do. That was the tragedy of it. There was no malfunction in the second engine, no broken part in the spacecraft itself. It worked precisely as intended. It simply worked in the wrong place, pointed the wrong way, because the stage beneath it had failed, and left it stranded and misaligned. A perfect machine performing perfectly into catastrophe. And no one could intervene. By the time the spacecraft came back into view of the ground stations, by the time anyone could see what had become of it, the burns were long over and the orbit was already set. There was nothing to be done. No command that could be sent, no correction that could be made. The fuel that might have raised the orbit had already been spent in the wrong direction, lowering it instead. The spacecraft was past saving from the moment those 4 seconds ended, though it would take hours yet for the slow physics of the decaying orbit to finish what that brief fatal misfire had begun. It fell in stages, patient and certain, around and around the darkened Earth, while the people who loved it pieced together too late the shape of what had happened. The plutonium panic. There was one more complication, one further detail, and it was the thing that turned the quiet, sorrowful failure of a science mission into a genuine international alarm. Mars 96 carried plutonium. Not as a weapon and not in any great quantity, but it carried it nonetheless. The 2 small stations and the 2 penetrators were each powered by radioisotope generators, devices that draw heat from the slow, steady decay of radioactive material and turn that heat into a thin trickle of electricity. This was not an unusual choice. Out at Mars, so far from the sun, where sunlight is weak and solar panels grow feeble, especially for small landers that would need to survive long freezing nights, a radioisotope generator was the only practical way to keep the little machines alive and working through the cold. In total, across all 4 of the small craft, the spacecraft carried about 200 grams of plutonium. It was sealed in the form of small pellets packed inside heat-resistant metal containers roughly the size of film canisters, which had been designed specifically and deliberately to survive the violence of an atmospheric reentry and the shock of an impact. 200 grams is not very much. It is by weight roughly the size of an apple. But it was plutonium, and it was now falling out of orbit on an uncontrolled path towards some unknown point on the surface of the inhabited Earth. After detecting the anomalies in the spacecraft's behavior, after realizing that something had gone badly wrong, Russia asked the United States Space Command for assistance. They wanted help understanding what was happening up there, and crucially, where the falling hardware might come down. And here in this exchange, the confusion only deepened. The Americans tracked an object as it spiraled downward through its decaying orbit, but they tracked the wrong one. In the difficulty of the moment, they had locked onto the spent fourth stage, the Block D-2, mistaking it for the spacecraft itself, or perhaps for the spacecraft and the stage still joined together. Based on that case of mistaken identity, they calculated a path, a predicted point of impact, and the path they calculated pointed toward the southern hemisphere of the planet and possibly alarmingly toward Australia. This incorrect prediction climbed quickly up the chain of command, gathering urgency as it went. It was passed to the National Security Council, the body that advises on matters of national safety. The Council took it seriously as it had to, and it alerted the President of the United States, who at that particular moment happened to be in Hawaii. And the President, acting on the strength of that urgent alert, picked up the telephone and placed a call to the Prime Minister of Australia to warn him that a Russian spacecraft carrying radioactive material might be about to fall somewhere upon his country. It was a dramatic scene when you picture it. A phone call between two heads of state in the small hours, set in motion by a tumbling probe and a couple of 100 grams of plutonium. The machinery of nations stirring to life over the fall of a single spacecraft. And it was, by the time the call was made, entirely beside the point, because the spacecraft was already down. While the warning was still working its way across the Pacific, while officials calculated and worried, and the telephone rang in Australia, Mars 96 had already completed its short and doomed life. It had already re-entered the atmosphere hours before somewhere else entirely far from Australia. Russia, for its own part, had estimated an impact in the eastern Pacific Ocean and had announced as much on the very morning after the launch. The two pictures of events did not match. The whole episode dissolved into a tangle of imprecise data and crossed wires and honest confusion. Different parties were tracking different objects, making different predictions and arriving at completely different answers. The fourth stage and the spacecraft were repeatedly confused with one another in the records, which is part of why the timeline remains uncertain even now. Times and locations shifted depending on whom you asked and which object they had been watching. And in the chaos of those first frantic hours, against the background of a Russian space program already in deep disarray, the clear and full and honest picture of what exactly had fallen, and precisely where and how much radioactive material it had been carrying, did not emerge all at once in a single clean statement. It came out instead slowly in pieces over time, against a background of alarm and uncertainty and competing accounts. The truth, when it finally settled into focus, was at once less frightening and more haunting than the panic that had preceded it. There had never been any real danger to Australia. The phone call, dramatic as it was, had been built on a misidentified object. But there was somewhere out there in the world 200 grams of plutonium that had returned to the surface of the Earth. And no one knew with any certainty exactly where it had come to rest. There is something almost poignant when you sit with it about the nature of that confusion. Here was a moment when several of the most sophisticated tracking and intelligence systems on Earth, the great networks built to watch the skies, all turned their attention to a single falling object and still could not quite agree on what it was or where it would land. The fourth stage and the spacecraft, tumbling separately through the night, were mistaken for one another. Predictions diverged. A warning crossed an ocean and reached a president and a prime minister and was already obsolete by the time it arrived. For all our instruments and our institutions, a small spacecraft falling out of orbit in the dark could still in 1996 slip through the gaps in our understanding and come down where it would on its own terms. And consider the small canisters themselves, the heat-proof shells around the plutonium. The engineers who designed them had thought carefully about this exact possibility. They had asked themselves, what if the worst happens? What if this spacecraft never reaches Mars and instead falls back to Earth? And they had built the containers to answer that question, to hold their contents safe through the fire of re-entry and the violence of impact. In a sense, those canisters were the one part of the mission that worked exactly as the worst-case planning had intended. They were built to survive a disaster, and a disaster came, and they survived it. The instruments failed to reach Mars, but the safety design did its job. The plutonium did not scatter and burn. It came down sealed, intact, protected just as the engineers had promised it would, into a desert where no one would ever find it. It is a small and strange grace buried inside the larger loss. The part of the mission designed for catastrophe was the part that performed flawlessly. The fall over the Andes. The end came in the small dark hours of the 17th of November. Mars 96 had circled the Earth perhaps 3 times in its dying orbit, but each pass dragging it a little lower, each brush against the upper air bleeding away a little more of its precious speed. The loop tightened with every revolution, the lowest point sinking deeper into the atmosphere each time around. And then on that third orbit near the bottom of its path, it could hold on no longer. It dropped into the atmosphere for the final time, and this time it did not climb back out. What follows when a 6-ton spacecraft re-enters the atmosphere is not gentle, and it is not slow. The thin air thickens with terrible speed as the craft plunges downward, and the friction of that thickening air builds on almost instantly into searing, blinding heat. The structure begins to glow white-hot. Surfaces char and peel, and then the spacecraft begins to break apart, shedding pieces, scattering fragments behind it, across a long and lengthening path. As it tears down through the sky, a streak of fire drawn across the heavens. The debris fell across a vast and lonely region of the world. The best estimates place the fall within an oval roughly 320 kilometers long and 80 kilometers wide. A great elongated footprint running from southwest to northeast across the map. That enormous footprint crossed first the eastern Pacific Ocean, and then swept inland over the territory of Chile and of Bolivia, up near the high deserts that climbed toward the spine of the Andes. The center of the predicted zone lay some 30 kilometers to the east of the coastal city of Iquique in the far north of Chile. This is the Atacama. It is one of the driest places anywhere on the face of the earth, a landscape of bare rock and pale salt and immense silence. A desert so arid that in some places no rainfall has ever been recorded. The air there is so clear, so free of moisture and light, that the region has become home to some of the greatest astronomical observatories in the world. Vast telescopes peering out at the very universe that Mars 96 had hoped to help explore. And in the early morning darkness of that November night, people scattered across the Atacama looked up and saw something burning in the sky above them. Eyewitnesses near the border between Chile and Bolivia reported seeing a bright object breaking apart high overhead, a streak of fire splitting the darkness. At around 50 minutes past midnight, they did not know in that moment what they were looking at. How could they have known? They could not have guessed that the falling light tracing across their sky was the wreckage of a mission to Mars. That it was the scattered burning remains of an orbiter, 2 small landers, and 2 penetrators, a whole fleet of explorers that had been built and dreamed over for years, that had been meant to settle gently onto the surface of another world. And that was now instead coming apart in fire above a desert on this one. The spacecraft is believed to have come down somewhere within that long oval, but the precise resting place has never been confirmed. And here lies the strangest and most haunting fact in the entire story, the detail that lingers long after the rest. No parts of the spacecraft and no parts of the upper stage have ever been recovered. Not a single fragment of the orbiter, not a piece of either small station, not a shard of either penetrator. The wreckage simply vanished, swallowed up by the ocean and by one of the emptiest, most desolate landscapes on the planet. And to this day, it has never been found. Searches were considered. The terrain is brutal, the area is enormous, and the records of where exactly things fell are imprecise. The desert kept what it took, and the plutonium fell with it. Those 200 grams sealed inside their heat-proof, impact-proof canisters were designed deliberately and carefully to survive exactly the kind of fall that had just happened to them. They are thought to have come through the re-entry intact, their protective shells doing precisely the job they were built to do, which means that somewhere out there in the cold waters off the Chilean coast, or buried beneath the sand and stone of the Atacama, or lost among the high folds of the Andes Mountains, There are small metal containers of plutonium scattered across a region the size of a small country that no human being has ever located in all the years since. They are out there still, quiet, unmarked, slowly decaying as plutonium does on a timescale measured not in years nor even in lifetimes, but in centuries. A tiny piece of a failed dream returned home to the earth, and never once reclaimed. It is in its own quiet way a strange and fitting and sorrowful monument. A mission that had been meant to bury its instruments deep in the red soil of Mars instead scattered them unfound and unrecovered into the soil and the sea of our own world. It went to ground, just not the ground anyone had intended. Why build it at all? There is a question that hangs over a story like this one, quiet but insistent, and it is worth sitting with for a while in the dark. Why build it at all? Why pour a decade of work and the labor of 21 nations, and the last reserves of a broken treasury into a single spacecraft, at the very moment when the country building it could barely keep its lights on? Why reach for Mars when there was scarcely enough to live on at home? It is easy from a distance to call it folly, to say the money should have gone elsewhere, that a struggling nation had no business spending its dwindling strength on another planet. And there is a kind of cold logic to that. But there is another way to see it, and it is perhaps the truer way. The people who built Mars 96 were not naive. They knew exactly how poor their country had become. They had felt it in their own unpaid salaries, in their thinning ranks, in the silence where a younger generation should have been. They knew that the odds were long, and the resources were thin, and the history was against them. And they built it anyway. Not because they expected it to be easy, but because to stop reaching outward would have been in some essential way to stop being themselves. There is something in the human spirit, and it seems to live most stubbornly in scientists and explorers, that refuses to let circumstance define the limit of its dreaming. The same impulse that had once sent the first satellite into orbit and that had sent the first person around the Earth did not vanish when the empire that funded it fell apart. It simply contracted into a smaller and more fragile vessel and held on. The dream of Mars became a way of holding on to something larger than the daily struggle, a way of insisting that the future was still worth building toward, even when the present was grim. And so the failure when it came was not the failure of a vanity project. It was the failure of an act of faith. These were people choosing to believe against considerable evidence that the work of understanding the universe was worth doing even in the worst of times, perhaps especially in the worst of times, when everything else is uncertain. The slow, steady questions of science, the age of a planet, the chemistry of its air, the trembling of its hidden core, offer a kind of anchor. They are bigger than any one nation's troubles. They will still be there waiting to be answered long after the troubles have passed. That is what fell into the Pacific on that November night. Not just 6 tons of metal and instruments, but a particular kind of hope. The hope that says we will keep asking, we will keep building, we will keep reaching no matter how hard things become. And here is the quiet consolation, the thing that makes the loss bearable to think about. That hope did not actually die. It cannot die as long as there are people who carry it. The spacecraft was lost, but the impulse that built it was not. It went underground for a while, like a seed in winter soil waiting, and in time, in other hands and in other countries and other decades, it surfaced again and grew and bore fruit on the surface of Mars itself. The instruments sank into the ocean. The dream did not. It only changed hands. There is a strange comfort in that thought, a comfort that belongs especially to the quiet hours of the night. So much of what we build will not last. So many of our reachings will fall short, will end in silence, will scatter unrecovered into the dark. And yet the reaching itself, the choosing to try, passes onward from hand to hand across the years, far more durable than any single machine. We are all of us part of a long relay of hope, carrying something forward that none of us will see completed. The runners change. The dream endures. Mars 96 was one runner who stumbled and fell, but the thing it carried did not fall with it. It was caught up by others and carried on. Think, too, of the smaller human stories folded inside the larger one. Somewhere in France there were engineers who had given years to the seismometer they called optimism, who had named it that as a small act of defiance and hope, and who would never see it do its work. Somewhere in Germany, in Braunschweig, there were people who had built the delicate sensors for the penetrators instruments, meant to be buried in the soil of another world that instead burned up in the sky above a desert. Across 21 countries, there were quiet rooms full of people who had each contributed some small, careful piece of the whole, and who each, on the morning after the launch, woke to the news that their piece was gone. None of them individually had built the spacecraft. Each had built only a part. But that is how the great projects of our species are made in the end. Not by single heroes, but by enormous distributed acts of cooperation, thousands of hands, each shaping a fragment, trusting that all the fragments will come together into something none of them could have made alone. That trust is a kind of love if you look at it closely. A willingness to give your careful work to a common cause, and to depend on strangers in distant countries to give theirs. When Mars 96 fell, it was that web of trust and shared labor that fell with it. And the wonder is not that it hurt so much. The wonder is that people kept doing it afterward, that they kept choosing again and again to pour their care into shared machines bound for distant worlds, knowing full well how easily it could all end in a streak of fire over a desert. To build it all in the face of that is its own quiet form of courage, the kind that does not announce itself, the kind that simply shows up the next morning and starts designing the next one. What was lost and what remained, and for the people who had built Mars 96, the loss was not an abstraction. It was not a line in a budget or a footnote in a report. It was deeply personal, and it was crushing. Many of them had spent the better part of 2 decades working toward this single night. They had lived through the collapse of their own country. They had endured the disappearance of their salaries, the slow erosion of the institutions they had given their lives, to the steady draining away of colleagues and resources and hope. Through years when almost everything else around them was falling apart, they had held on stubbornly to a dream of Mars. And then, in the space of a single night, in 4 unobserved seconds high above a dark ocean, all of it sank quietly into the Pacific. One of the senior figures in Russian space science, on hearing of the failure, spoke with a colleague at the Space Research Institute in Moscow. The institute, known by its initials as ZK, which had long been the heart of the country's planetary exploration. The mood among the planetary scientists in the hours and days afterward was one of profound despondency. There is a particular and terrible kind of grief that comes when years of careful work end not in a result, not even in a clear and instructive failure, but in nothing at all. In silence. In a fall. In instruments that never got the chance to take a single reading, that never sensed the thing they were built to sense. The seismometer named Optimism, built with such hope and such care, would never feel a Marsquake. It would never take the pulse of another world. It now lies in pieces somewhere on the floor of the ocean, its hopeful name a small and painful irony. The damage spread well beyond Russia's own borders. Mars 96 had been an international mission, a web of trust patiently built up over many years between scientists who had learned against the grain of their century to work together. And its failure frayed that web badly. Foreign scientists who had invested their own instruments, their own funding, and their own careers in the project were left in an instant with nothing to show for it. Coming as it did after the disappointing results of the earlier Phobos probes, the loss of Mars 96 eroded the patience and the confidence that had once made other nations so eager to fly their hardware aboard Russian spacecraft. A trust that had taken a decade to build was badly shaken in a single night. And for Russia itself, Mars 96 marked something very close to an ending. It was the only Russian deep space mission of the entire decade of the 1990s. And after it fell, the silence stretched on and on for many years. While American and European spacecraft went on to map Mars in extraordinary detail, to land rovers that crawled across its surface for years on end to discover the ghosts of ancient riverbeds and lake beds, and the chemistry of an older, warmer, wetter world, Russian planetary scientists could mostly only watch from the sidelines. The grand tradition that had once sent the first probes to Venus and the Moon was reduced for a long while to memory and to longing. It would be 15 long years before Russia tried again to reach beyond the orbit of the Earth. In the year 2011, a spacecraft called Phobos Grunt was launched at last, meant to fly to that same small Martian moon Phobos and to scoop up a sample of its ancient soil and carry it home to Earth. It was the revival the community had longed for through all those barren years. It was the chance finally to repeat what had been lost, to close the circle, to redeem the long silence. And it failed in almost exactly the same way. Phobos Grunt reached orbit just as Mars 96 had. And then its engines never fired to send it onward, just as Mars 96's push had never truly come. Like its predecessor before it, the spacecraft became trapped in low Earth orbit, circling helplessly, while engineers on the ground fought to revive it, and the batteries slowly drained. And like its predecessor in time, it fell back to Earth and burned. The lead scientist on the mission, asked about the looming loss, said simply that he felt grief. The same word. The same ocean of feeling. The same long shadow reaching across the decades from one failure to the next. And yet, the story does not end only in loss. It would not be honest or complete to leave it there. The ideas inside Mars 96 did not die with the spacecraft. They could not be drowned. The concept at the heart of it, the idea of small, simple, low-cost stations spread out across the surface of Mars, all listening together for the trembling of the planet, but all measuring its weather and its magnetism in concert, that idea was too good to be lost. It inspired later designs, later proposals, later missions in other countries and other decades. The dream of placing a seismometer upon Mars, of finally feeling the deep heartbeat of another world's interior, was picked up and carried forward by other hands. And decades later, that exact dream came true at last. A spacecraft set a seismometer down gently upon the Martian sand, and it listened. And for the very first time in human history, it felt a Marsquake rolling through the deep rock of another planet. The trembling that optimism had been built to sense and never did was sensed at last by an instrument that owed something to all the dreaming that had come before it. The seismometer that fell into the Pacific had not been the end of the idea. It had only been one of the beginnings of it. So perhaps that is the gentlest and the truest way to remember Mars 96. Not as a humiliation and not as a curse upon a nation, but as a hand reaching out into the dark in the worst of all possible times, by people who had every reason in the world to give up, and who chose instead to try. The spacecraft never reached Mars. That much is simply true. But the reaching mattered. The building mattered. The 21 nations who set aside the old divisions and came together to make a single beautiful, impossibly ambitious machine that mattered too, and it still does. Tonight, somewhere in the high and ancient silence of the Atacama Desert, or far beneath the cold gray waves off the coast of Chile, the scattered pieces of that machine rest where they fell so long ago. They were meant to lie in the red dust of another planet, gathering up its secrets, listening to its quakes, watching its slow seasons turn. Instead, they came home and they settled quietly into the ground and the sea of the world that had made them. It was not the ending that anyone wanted, but it was an ending, and there is a kind of peace to be found in that in the end. The dream did not survive in metal. It survived in something more durable than metal. It survived in the people who kept on dreaming, and in the missions that came after, and in the Marsquakes that would one day be heard. And the desert keeps its small, bright, secret cargo patient and unhurried, beneath the same vast and starlit sky that Mars 96 had once hoped to cross. Rest now. The spacecraft has long since come to rest. And so gently may you. Good night.